Hi YouTube, my name is Brian Garness and I'm an application engineer with a Siemens automation distributor here in the Midwest. My plan is to post step-by-step instruction guides for some of the proof of concepts that I get involved with. Since I use YouTube as a reference, I plan to post only on topics that do not already have a good video. My plan is not to do a lot of video editing other than splicing segments together. I have no scripts, so this is not always going to go as smooth as I would like. I will conversationally describe the process as I would to a customer. My goal will always be to give you something that is reproducible and will form a basis for your projects. I welcome your feedback. Today I'm doing a proof of concept for a customer that is adding a new winder section to a machine line. The new section is going to have a Siemens PLC, most likely from the 1500 family, and they need to exchange certain pieces of data with the other end of the machine, which is operated with either ControlLogix or CompactLogix PLC. So this device here is one in a series from Hilscher, the Net Tap devices that do protocol conversion. They're capable of multiple interfaces. They have a serial 485 interface for Profibus or Modbus type protocols. And the one we're looking at today is the 151RE. That means Ethernet on the X2 port on the top there, and Ethernet on the X3 port. Each side has a 2-port switch and will accept different protocols. We're going to take a look at those. So the protocols that are available for X2, that side of the device is capable of doing a number of slave protocols. Profinet, in that net world, a slave is called a device. Ethernet IP is an adapter, and PowerLink is a control node. That's the X2 side. We'll take a look at the guts and show you the difference, but the X3 side is capable of doing both the slave protocol and the master protocol for these different protocols. And in the middle here is just showing the firmwares that need to be downloaded to the device in order to enable those protocol stacks. So inside the device here, we're looking at the functionality provided by a couple of proprietary chips that Hilscher makes. The first on the X2 side, which is capable of slave protocols, is the NetX51. Basically, that side can be configured in any one of those networks that we looked at as a slave device. So in this case, we're showing the PLC talking to multiple slaves, including the Net Tap device. On the other side, the X3 has a NetX100 chip, and that is capable of doing slave protocols or even master protocols for several of the ones listed on the other page there. In essence, that's the device that we're going to use, and we're going to link together a 1511 Siemens PLC. We're going to go Profinet over to the X3 port. That'll be a Profinet device. The Net Tap device itself is programmed with a USB port here in front, and the Ethernet IP side is going to be talking to this CompactLogix, and that will be configured as a Ethernet IP adapter here and a scanner on the PLC side. So we'll break this video into kind of 3 parts. First, we'll go through the configuration here on the Net Tap. Part 2, we'll go through all of the configuration to set up the Profinet network with a device. Then part 3 will be taking a look at getting that data from the Siemens PLC and taking a look at it in the producer-consumer world of the Ethernet IP. So we'll get data flowing from the Siemens PLC to the Compact Logics, and then we'll have data flowing in the reverse direction for the Siemens PLC. Okay, all I've done is added IP addresses that we'd like our devices to operate on. You can see that the Siemens side for Profinet is a S7 1500 processor connecting on the 192.168.2 network to the X3, which is also there. The Ethernet IP side, we're using a 3 network. I plan to have 3.10 up on the X2 and 3.1 on the PLC itself. So in this part of the video, we're going to configure everything needed in the Net Tap so that the device can be recognized on each side of the device, and then also mapping the data from one side to the other. The tasks that we need to accomplish are here. So we'll get connected via the USB. The USB, once it connects, maps to a standard COM port, which is very typical for software like this. The software, once we start it, will detect that COM port, detect the device, and then offer it up as an option. Once we get connected, we're going to select protocols for the ports. As you can see in the diagram, we are going to select Profinet on one side, Ethernet IP on the other. Once you do that, that determines which firmware is required to support those protocols, and it offers a simple select and download button for the firmware. Next, we will set up the data exchange for the Profinet side. To be a Profinet device, you need 2 things. You need a Profinet name, which is just a alphanumeric name that is used in identifying the device as the protocol starts up. The controller, which is our 1500, will ask for that name and then transfer to it through the initialization phase the IP address that it should operate on, and some more of the configuration that we configure on the TIA portal. The other thing we'll do is set up the telegram, which in our case will be 12 bytes in and 12 bytes out. And that should do it on the Profinet side. Then we move on, and the next phase will be to set up the Ethernet IP. And very simply, for that, we'll need a IP address for the device port X2, and we have that on our diagram. And the other thing we need is to define the data type and size for produce and consume, which will match up to our other side, which is 12 bytes in and 12 bytes out. Lastly, then, we can map byte to byte using the mapping part of the configuration to send data from one port to the other port, and vice versa. We have 12 bytes flowing in each direction. So to do the configuration, I'll bring up the Hilscher software SICON-net, and here it is, just ready to start configuring. So firstly, I need to select the device that we're using, and I went to the vendor tab here, and we'll go down in the gateway standalone slave device category, until we get to the Net Tap151. So there are pre-configured protocol pairs here. I'm going to just select the general device, and that will allow us to configure each protocol on the fly. Either double-clicking or right-clicking and saying Configuration Gateway will bring up this first screen of the configuration where it's going out and scanning for Hilscher devices. And in my case, it found this NT151 RERE. So I will select it here with the checkbox, and I am ready to select the protocols for each port. The port X2, as you'll remember, is the slave-only protocol port. And what we're going to do is select our Ethernet IP adapter for that port. And that starts to narrow down firmwares here that are available for that include Ethernet IP on port 2. Next, I will select a Profinet device for port X3. And that narrows us down to one firmware for download. So next I would click download. I've already done it, so I'll spare that time. It only takes a couple of minutes or less, and you will have the correct driver protocols in the device for connecting. What's left is to get signals mapped between the two. And first, it brings up a standard default config of 32 in, 32 out on each side, which I believe is the max data transfer for this device. At this point, we're done with the main gateway configuration. We're going to come back there and revisit the mapping once we've defined each port in configuration. So I'll start with the Profinet side. What we're going to do here with the Telegram is add those 12-byte modules that I talked about. So firstly, we'll have 12 bytes of input in slot 1 and 12 bytes of output in slot 2. So that takes care of the Telegram. Next, we just need a name for this device, and I'll just put in Net Tap for the device name. We'll need to remember that so we can use it later in configuring the network on the TIA portal. Down here, you can see that the address is all grayed out, and a note that says that the device address comes from the Siemens controller. So that'll be part of the PLC configuration. What IP address should this device be operating on when it's exchanging data? And that's all handled with the initialization phase of Profinet. So we've now completed the things required for the Profinet side of this, and we can move on to the Ethernet side, which is a little bit different. And we'll do that by going right-click, Configuration, Ethernet IP. And the things that we need for the Ethernet IP are, like I said, a little different. We need to just give it an IP address and give it a subnet mask. So we'll create from our data network diagram 192.168.3.10 and a class C subnet 255.255.255.0. The other thing we're going to configure is the number of bytes from being produced out of the adapter, and we're going to set that to 12, and the number of bytes consumed by the adapter, and that's also 12. Apply those changes, and then when we go to signal configuration, there's really nothing left to do. What I've found, this is able to edit the data types of the transfer, but the Ethernet IP side is not capable of adapting. Let's say if we defined 3 integers and then 4 reals and then 4 double integers, it's not capable of, even if we went in and edited this signal to be those data types, it's not capable of picking them up. It needs one array of data on the Ethernet IP side. And the last part of this video, we're going to show how to transfer different data types between the two processors via these 12 bytes. So we're not going to edit at all the content of the 12-byte array in and out. Lastly, we need to come back to the configuration of the gateway where I mentioned the signal mapping. And now we have 12 bytes on each side that need mapping. And what we can do is just do an automatic mapping at this point, where it's just byte 1 from one side to byte 2 of the other side. And I'll let it do that for right now. Once I apply that, we can see that there are 12 bytes moving in the direction from X2 to X3, and there's also 12 bytes down here moving in the direction of X3 to X2. So at this point, we've finished the configuration for the Net Tap, and data should flow. Again, we have to observe that the Siemens side is going to want to see data types that are more than 1 byte in the correct order. Siemens observes a big endian byte order, and the control logics and Rockwell observe a little endian. So right now, what we're going to do is get this set up, get data flowing through the bytes, and then we'll see the most effective way to transfer more complex data types. Complex meaning more than 1 byte. Let's say 16 bits or 2 bytes for an integer, and then or 32-bit 4 bytes for a double integer, or again the same 32-bit 4 bytes for a real data type. We'll look at that in the last phase of this. So the next step, we will actually go ahead and set up a Profinet network and make sure that we are connected from the Profinet side first. We'll get all green lights there, and then we'll move on to the Ethernet side. So last thing in this video, this part of the video, is to download this configuration, including the 12 bits on each side and the data mapping to the device. The device will actually reset, there it goes, as part of this configuration download, and then it will start operating as the device and adapter that I configured. So the next phase will be again with the Siemens TIA portal, connecting the network to the device. Okay, we're going to move on to the Siemens TIA portal and setting up the PLC program and network for the Profinet side. We're going to need one thing back here out of SICON-NET, and that is an export of the GSD-ML file. I right-clicked on the Net Tap, additional functions, Profinet device, export GSD-ML, and I will place that in a area where I can get at it from my virtual machine running the TIA portal. So that's the last thing we should need from SICON-NET, and we're going to move over to my virtual machine that has a blank project started for the Siemens side. I'm not going to go through every point step by step. I'm not going to teach you how to program the portal, but I will go through each step as needed here. This is a completely blank project. So the first step is to add my PLC. and I will do that from controllers. It's a 1500 CPU. It's a 1511. And I happen to know it's that part number, and it actually called up a firmware and everything. That will actually start a project which will give me access to a device configuration and ultimately the network configuration. So I'll start here with the PLC itself, and I will define the IP address that we talked about from our network diagram. We'll move this PLC onto the 2.1 address. There happens to be a digital input card. I need to put that in just so everybody's happy. As I download this configuration, we aren't actually going to be using this card, but this is all that's really needed. I can compile that, check it out. No actual errors. The next thing we'll do is configure the network, and in order to add that station, it's not going to be here in your catalog unless we import that GSDML that we just exported. So if I go to manage GSDMLs, I have the GSDML on my desktop here, and I have this pointing to my desktop, and I can highlight that and click install. That will give me access to the Hilscher Net Tap151 GSD file. This is a generalized GSD file, meaning if I decide to change my number of bytes transferred later, I don't have to go export and re-import and all that. I should be able to find this under other field devices, the one that we just imported, and additional field devices, Profinet IO. Okay, it looks like I don't know where I'm going to find this. Gateway, there we go. It's under other field devices, Profinet IO, Gateway, Hilscher Net Tap151, and there it is. At this point, I can just drag that right onto my network, and you can see that it's already named, the name of it's already NetTap. It is not connected or assigned to any controller. So if I click on not assigned, I have the option to assign it to the controller, which sets up this correct network path for the control. As you remember, it should have a IP address. We don't need to change it. I'm just going to go in here to the properties of the device, and we can actually see that it assigned 2.2 to the interface, and I believe that matches up nicely with our diagram. This port will, this device will be operating on 2.2. That's all good. Next, I'm in the device config for the NetTap. It shows up here as a DP norm device, but it is our NetTap151, and there's several ways to get there, but basically what we've done is flipped over here to the device view of that. Over here in the catalog, I can now insert telegrams. As you remember, when we made it, we inserted 2 telegrams for this. We had subnet 1, or slot 1 was 12 bytes of input, and all I do is drag this over. Then I can grab 12 bytes of output for slot 2, And now that should match perfectly with what we set up in the Net Tap. We have a device, if I go back to the network view, we have a device name, Net Tap, and we have the same telegrams defined. I can save this project, download it to our device. First we search for the device. Okay, it found a suitable target device, and then we load that. I'm downloading the hardware configuration and the software. It had a project in it previously, so I'm just telling it to go ahead and load. As I finish here, it's going to go ahead and start the PLC running. If I go online, right here, it should show us the status. That's good news. We've got a network configured, and we have green check marks in that network. Next thing we can do, we can check the device configuration, and we can learn the addressing scheme for that device. I actually don't like that. I'd like them all to be the same for the input words and the output words. So I'll have to go offline and configure those addresses to be the same on the input and the output. That'll just make things a little less confusing. I'll save the project, download, and that will readdress that data. Lastly, in the next steps, we're going to want a way to view that data. And the simplest way with Siemens is to set up just a watch table. Watch and force tables, I'll add a new. Here in the watch table, we are going to map the 12 bytes in and 12 bytes out that were defined over on the Net Tap. And we can do that simply. Just as a reminder, we're going to go back here. I kind of changed courses a little bit. I mapped in this telegram here at 0. That is the input bytes. And also this one at 0. We have 12 bytes as defined from 0 to 11 as I/O in the Siemens PLC. So going back to the watch table, we're going to just define those as bytes. For we're starting with input byte 0. We use a feature here. It's kind of like an Excel spreadsheet. I can go ahead and add 11 more rows, and that will bring out all of the bytes from our input that's coming from the Net Tap. If our output bytes QB 0, those will be defined here, and I'll bring out 11 more rows, and that's all of our output bytes, meaning from the Siemens out to the Net Tap. I'm going to choose to display these all as decimal. So I'll go ahead and mark all of those as decimal. That means that it'll show me here in counting numbers rather than hexadecimal format the value of each number. Later on in another video, I plan to take these 12 bytes and then break them up into different data types, words, which would be integers, 16-byte integers. If we take 4 of these bytes, we can either make a double integer or a real data type. There's some complexities in transferring those other data types. When you're talking about the big endian byte order in the Siemens side, and then as translated to the little endian byte order in a Rockwell PLC. So I decided to break that off into another video. For right now, we're just going to show data flowing back and forth from the Siemens PLC here to the Rockwell PLC as bytes, and then later on in a follow-up video, I'll break that into integers, double integers, and reals. That pretty much does it here for configuration on the Siemens side. I'll go ahead and go online with this configuration. There may be data in there coming back and forth already. So we hit the glasses here and we can see that all the data coming in is 0 and all the data going out is 0. We've got a nice tool here. If we decide we want to send a 1 over to the control logics, all we need to do is put a 1 there and hit this lightning bolt, and that will actually put a 1 in the first byte of the telegram. Okay, now for the part that I was kind of dreading. I am going to try to search back in the memory banks and come up with a basic configuration here for the control logics PLC. So I started this new project. It's a Net Tap demo, and all that I did was called out this 5370 controller, which is Compact Logic's. Here's the part number for that. It's a simple shoebox PLC. When I say that, I mean a PLC that has built-in I/O. Just for quick reference, this is the actual setup that I'm programming. The Net Tap in the middle here, minus the USB cable that I had connected to it for programming it. The 1511 PLC from Siemens, and the project. This is a Compact Logix that I just started the project for. Let's go ahead and try to get data flowing through the Net Tap here. This should be the last step in making that happen. Now, you guys with an AB logo tattooed on your arm, I'm sure that you're going to find things that can be done better, different, wrong. I've done something wrong. Please make a comment below. But my understanding is I need to get some controller tags built for the produce and consume model of the Net Tap adapter. I went ahead initially, and the first time I went through this, I took a EDS file from the DVD and added that. When I was adding the device, I added the Net Tap EDS file. So if I just now come here, I can call that up just by calling up Hilscher, and I have the Net Tap device. Here, I'm just going to call this Net Tap, and for Ethernet IP, the important properties are the IP address, and just as a reminder, this is the network that we're setting up. We have a 192.168.310 planned for that port, and the PLC itself, we're going to try to put on 192.168.3.1. We'll do that next. 168.3.10. Okay. The telegram coming through is configured here. We're going to leave it in compatible mode. exclusive owner, and we are going to call for 8 bytes of SINT data type. That is a signed 8-bit data type. What we're going to do is just call out 12 of those as input and 12 of those as output. Okay, so that pretty much takes care of this station. We've done the important things for Ethernet IP, and that should bring up a device here. We can close that, and you can see that we've added now these 12 bytes are available as a 12-byte data array of 0 through 11 here as input, with also some diagnostics on the channel that are automatically added. And then we have 12 bytes of output. The last thing we need to do is set the IP address of the compact logics. And I'll go here to Internet Protocol. It looks like that is not a doable thing while you're offline. So we're still offline with this project. We're about to send it to the PLC. What we're going to need to do is connect. What I did here is connect through a USB port. Okay. And there is the PLC. I'll go online with it. That sets the project path to the USB and takes me online. I should now have access to the Internet Protocol, and what we want to do is make sure that this is set 192.168.3.1. It was there because I'd had to work through this problem of configuring offline. Now connected through the USB, I just set this to the correct IP address for our network plan. Just a reminder, so the PLC is at 3.1 and the Net Tap was at 3.10. So they're in the same subnet, and I'll use a class C here as well. And that's all I really should need to do. This PLC should now be reachable. I'll go offline, and this should now be reachable with Ethernet IP. And there it is. I'll go online. That now sets our project path to Ethernet, which is more desirable. I can go ahead and disconnect the USB port. I'm now online. I have access to my controller tags, and I'm going to switch from the edit view to the monitor tags view, and that expanded everything. And you can see that we have here in expanded view of the input data, Net Tap input. The Net Tap input, it's indicating that there's no fault. It adds this little header to the input, and it's in run mode. The actual data coming across from the Siemens side, if we remember, we put a 1 in the watch table on the Siemens side, and we have a 1 coming through here. To confirm data going the other direction, I'll just put a 99 in data byte 0, and we'll flip over to, we'll try to flip over to the Rockwell side. I had to fix a small problem with the screen capture software running. I wasn't allowed to switch between my virtual machines. So now we can freely do that. And if we go back to the Siemens side, you can see that we have a 99 coming across in byte 0. Just to check out a little bit more of the channel, let's enumerate these values up to 12. So 12 bytes going across. If I send those to the PLC, we should see those coming across into the input bytes on the Rockwell side, and we do. Let's do the same thing here. Let's start at 100 or 101, 102, 103, 104. You get the idea. So this is the data bytes headed back to the Siemens side. Let's take a look here. And this is going to lead into the next video. You can see that the data type here is being forced to a signed integer, and I did not see any other option except for signed bytes as we made the device here. There wasn't anything else we could do. So that means that when we get past 127 or 128, I'll put in 129, you can see that we can't send that. It wants just 0 and a negative numbers. That's going to prove to be a problem a little later. But for right now, we're just going to prove out the data channel. Those should be in there. If we go back here, you can see that we have the 101, 102, 103, and so on. That proves that we are allowed to send across data bytes. It's getting there. The next video, as I said, we'll talk about dealing with larger data types in the byte. So we'll be combining these into words, which is 2 bytes, 16-bit, double integers, and reals. At this point, I think that takes care of all of the configuration on all 3 phases of this. And the next video will go into to breaking this apart. Thanks for watching. Please leave comments or corrections below. Let me know your ideas for any follow-up videos to this. And see you next time.